are. Our instructions here are to find the inverse function if there is one. So the very first thing what I need to do, I need to do the horizontal line test. So let's go ahead and graph that. Okay? So go ahead and graph that. I would make sure you hit the Z standard window, because otherwise you're going to get a pretty funky graph there. So graph that in the Z standard window. Does that pass the horizontal line test?
Yes.
Yes, it passes the horizontal line test. So now what I need to do is I need to go ahead and figure out the domain and the range. What's the domain of this graph? Domain, remember, is left or right?
4 to infinity.
4 to infinity. Do I include 4? Yep, I include 4. What about the range? What's the range?
0 to infinity.
0 to infinity. Do I include 0?
Yes.
Yes.
Yep, I do. Okay, so we're going to come back and use that in a little bit. Very first step, y equals square root of x minus 4. Everybody should be able to do that. What do you do next? Yep, switch them. Good. Square root of y minus 4. What do I do now?
You get y by itself.
Yep, square both sides first of all, so I get x squared equals y minus 4. What do you do now? Add 4 to both sides. So I get x squared plus 4 equals y. Very last step is to do what?
But f negative 1x thing is negative y.
Okay. X squared plus 4 equals f inverse of x. Now what I got to do is see if there's any restrictions on my domain. So remember, the domain of this equals the range of what? The domain of f inverse of x. Domain of f inverse equals the range of the original function.
So range would equal 4 to infinity and domain would equal 0.
Right, so my domain here, folks, is going to be what?
0 to
Perfect, 0 to infinity. Good. That's why it helps to do this from the get-go. Do that from the get-go. Because what that's going to do then is tell you right away what your domain is going to be.
So you don't have to do range.
Nope, you don't have to do the range, just the domain. Okay, let's go ahead and look at another one. Let's go ahead and look at another one. So x minus 1 over x plus 2. So very first step, we need to decide, does this pass the horizontal line test? Does it pass? It passes the horizontal line test. Yes, it does. Now what I need to do is find the domain and the range. So the domain, try again. Negative infinity to what value? Negative 2. Negative 2 to infinity. The reason we use negative 2 is because that's where the denominator is undefined. Okay, what do we think about the range? What's the range going to be? Negative infinity to what value? Where's there a break in the graph, guys?
1 or 2.
You're right, it's 1. And then from 1 to infinity. Okay, so there's a break in the graph vertically at negative 2 and horizontally at 1. All right, so let's go ahead and start. Y equals. Now, you might want to pay attention because this one is going to get kind of interesting.
I'm already confused with the domain of
Okay, there's a break in the graph vertically at negative 2 for the domain. Okay, and then there's a break horizontally back. Okay, so now what we're going to do is switch. X equals y minus 1 over y plus 2. Now the question is now, how do you solve that for y? Yeah. So if you didn't catch that, we're going to multiply both sides by y plus 2. Basically get rid of the denominator. Now when I do that here on the left side, I get xy plus 2x equals y minus 1. Now what I need to do is get my y's all on one side. So what I could do is go ahead and I could subtract y, and then I could subtract 2x, that would work. So on the left you get xy minus y. On the right I get negative 1 minus 2x. Now what we do is go ahead and factor out an x, and we get our y, and we get x minus 1. So what's going to be our very last step? Divide by x minus 1, good. So here I get y to equal negative 1 minus 2x over x minus 1. Or f inverse of x. What's my domain going to be on this one? Yep, negative infinity to 1. And from 1 to infinity. So that one is probably one of your most difficult ones you're going to have. Okay, we went through the first two and those seemed a little bit easier. This is probably one of your more difficult.
Why do we
Yeah.
have to do that if we do pass the original line?
It does pass it. It does not touch the graph at any two points. It only touches it
Oh,
once.
because it's got the
Right.
different lines and
Right.
it's only on one line.
Yes, yep. It's only on one line at the same time. Doesn't ever touch it twice,
Yeah,
so.
that makes more sense.
So very last thing we're going to do is we're going to talk about one more concept of an inverse function. And one of the neat things about this is it actually relates to what we did last section. And so if we compose the two and their inverses, that's all this is saying. If you compose the two, you will get it to equal x. So if you compose the two functions, if they're inverses, it will equal x. And so let's go ahead and look at an example of that. It says show that f of x and g of x are inverse functions. Show that they are inverse functions. So now in order to do that, what we need to do is we need to show this. Oh, wrong pen. Let's go with that.
That's really fat.
I know. We need to show that this is the case and that this is the case. We need to show that f of g of x equals x and g of f of x equals x. And we went over this last section. You guys seem to do really, really well. So now, yeah, this does get kind of interesting. Because remember, the first step is to replace this. And what do I replace g of x with?
6 over x is 4.
Okay, so I'm basically taking f of 6 over x plus 4.
Because you're taking the G.
Right there.
Oh, yes, okay.
So now, where do I put the 6 over x plus 4? Where do I put that?
In the bottom of
I put it right here. Okay? So now before you panic and think, oh my gosh, I can't do this. First of all, I have 6 over. In place of x, I'm going to put 6 over x plus 4. And then I need to subtract 4.
Whoa.
So it's just 6 over x.
Perfect, because your 4's cancel. Right?
That's the answer?
So you get 6 over x. Now the interesting thing here,
It's 1 over x.
for those of you wondering,
6 over 6.
okay, another way to write this is
1 over x.
divided by.
So on problems like these, do you go top to bottom?
Hey, couldn't 6 over 6 be 1?
6 over
Is
6,
that the answer?
no, not yet. I divide by multiplying by the reciprocal, and what happens to your 6's? They cancel, and it leaves you with
Yes.
How much
x.
are we?
So that one is done.
Oh, so the answer is.
That's it. The answer, if you do this right, you will always get x. If you've done it wrong, it's kind of like a
So why would we
proof
just
thing.
not do it? Just
We
do
just
So
it.
write
let's-
x?
Yeah, but you're done with that one. Now this one, the question is, can you just write x every time? No, because I'm looking for your work. This is
She
like an
wants you to
essay
show.
question.
It says show.
That's
Yeah. So now let's look at the next one. Very first thing you're going to do you have to replace f of x with 6 over x minus 4. Now this one actually goes a little bit easier.
Yeah.
Where are you going to put the 6 over x minus 4?
Into the X.
You're going to put it right over here.
But that's cool. Right there.
So I have 6 over x minus 4 and plus 4. Now, one of the things about this division is when you multiply this, it ends up coming out to be x minus 4. If you want to know how that happened, you can see this step right here because it's the same thing. So you're ending up x minus 4 plus 4. What's x minus 4 plus 4?
X.
X.
Wait, hold on. How'd you do the 6 over x minus 4 on the bottom? Did you have to take x minus 4?
I plugged it in right here.
Yeah.
I plugged it in right here.
No, how do you solve it? Like,
You just divide it by this, so it would be 6 divided by 6 over x minus 4. And then what ends up happening is you flip them. And so if you were going to divide, for those of you wondering how did that come out to be?
okay, I got it.
You get 6 divided by 6 over x minus 4. Okay, division means you multiply by the flip. So there you go. And they cancel. And it leaves you with x minus 4. And then you add 4. Now that's obviously a little bit more in depth than most of them will be.
So the answer is x.
Yep, the answer is x.
Oh, yeah.
Very last thing. You need to graph your inverse graphically. Inverse graphically. Okay, very last thing. This is very, very easy. Remember how we said you switch x and y? All you're going to do is switch them. So if this is at the point 0, 1, flip that, what do you get? 1, 0. There's a point. Okay, this is at the point negative 1, 0. So 0, negative 1. So basically what you're going to do is you're going to flip enough of them so you can get a graph. 1, 2 goes to 2, what? 2, 1. So do you see I'm just picking points and I'm going from there? So another one would maybe be down here. That's negative 1.5, negative 2. So that will be at negative 2. That'll be at negative 2, negative 1.5. So right about here. And so what ends up happening is if I graph that and just connect those dots, now, one of the things you need to remember is from our original very first talk, we said that there is an invisible line here. Remember that? It was on the identity. So that might help you too. If you keep in mind.
How did you know that there was a curve right there?
Yeah, I don't get that either. How do you know
Okay.
it's
She cheated. She twisted it.
This is one of the things. Imagine that you've got an invisible line there, that red line, that dashed line. That is the mirror. And so what you're doing is you're drawing the mirror image. That is what the inverse function is. It is the mirror image.
But wouldn't that line come down then if it was the mirror image? Like, 'cause
Imagine,
it looks like it's turned and not flipped.
imagine you are folding on the red line. If you fold exactly on the red line, that is what you're going to get. It's gonna, well, maybe it should go down. If you're wondering, maybe it should go down this way a little bit more. Okay. So anyway, basically you're going to transpose the x and y's. Here's your assignment. It sounds like a lot, but it's really not that many problems. 2 through 24, the evens. You have 28, 30, and 32. You have 38 through 43 and 55 through 58. So you have 12, 13, 14, 15, 18, 19.
You are
So you have about 23 problems.
That is
So
a lot.
every
That's 22